I want to teach us how to differentiate implicit of functions. We are going to solve as many as you can do under implicit of functions in calculus. Now when you have something like this in x, open bracket, x plus y close bracket square equals to 5, and we have to differentiate it under implicit. First thing we do is that we expand this bracket, and when you expand this bracket, you are going to have x squared plus 2xy plus y squared equals to 5. That's the first thing you have when you expand this bracket. Now when you want to differentiate in implicit of functions, what's the differentiation of x squared? That is 2x. Now we use this power to multiply this, and we subtract 1. When you use power to multiply, that is 2x. When you remove 1, that is 1. That's why we have 2x. Now in implicit of function, anytime you differentiate x, you will not write dy dx at the back. Now plus. Now look at this one. This one involves x and y. So you are going to differentiate x, you differentiate y separately. Now when I differentiate x, what is the differentiation of x? That is 1. And I told them that you differentiate for x in implicit of functions, you will not write dy dx. When I differentiate for x here, that is 1. So I'm going to have 2y left. Plus, I will not differentiate y. When I differentiate y, what's the differentiation of y? That is 1. And anytime I differentiate for y, I'll put dy dx. If I differentiate for y now, 1. So I'm going to have 2x left. 2x dy dx. Why do I put dy dx? Because I differentiate 1. Plus, what differentiation of y squared? That is 2y. 2y. Because it is y, I will write dy dx. Equals, what differentiation of 5? That's 0. That's 0. Now, let us bring the ones that are having dy dx together. This one is having dy dx, that is 2x dy dx plus 2y dy dx. Because we are bringing those ones that are not having dy dx outside. So this one, when you take it outside, it's going to be minus 2x. When you take this 2y outside, it's going to be minus 2. So what's that next thing to do? Just say dy dx into bracket, so I have 2x plus 2y plus 2y. The dy dx is common, equals to, so minus, you can just hit minus, open bracket, 2x plus 2y. So x plus 2y. Now we are looking for the y dx. That means I will divide both sides by 2x plus 2y. All over 2x plus 2y. All over 2x plus 2y. So this one cancels this. That means our y dx and dy dx will be equals to minus, open bracket, 2x plus 2y, close bracket, all over 2x plus 2y. So this one cancels this. That means dy dx equals to minus 1. That's number 1. The implicit of function. Let's take another example. We are still under implicit of functions. Now we are given x squared plus y squared equals to 4 to differentiate. Now what is the differentiation of x squared? That is 2x. And I've told us that anytime we differentiate for x in implicit of functions, we don't write the y dx. Don't forget. Plus, what differentiation of y squared? That is 2y. 2y. I differentiate y, so I'm going to write 2y dy dx. What differentiation of 4? That is 0. Now this one is having dy dx. Bring this 2x outside. So that means 2y dy dx equals to 0 minus 2x, which is also minus 2x. But I'm looking for dy dx. I'll divide both sides by 2y. All over 2y. All over 2y. So 2y cancels 2y. That means dy dx will give me what? y dx is going to equal to 2 cancel 2 minus x all over y minus x all over y. Now let's go to number 3. Now this is number 3 for implicit of functions. Now he told us that this is 4y square x. We are differentiating y. We are also differentiating x. Now if I want to differentiate y first, if I differentiate y, as you can see, you now say 2 times 4. That will be 8y. And when you subtract 1, it's going to be raised to power 1, and that's, you don't need to write it again. That means 8y x dy dx. Why do I put dy dx? Because I differentiate y. And there is 4 in front. That 2, instead of say 2y, but there is 4 inside, I use that 2 to multiply the 4. So, but the x is still there. I only differentiate y. That is 8yx dy dx. Now plus, because we are going to differentiate x also. When you differentiate x, x here is 1. What differentiation of x here? That is 1. So if it is 1, so we are going to have 4y squared left. 4y squared. Or you cannot put dy dx there because I differentiate for x. Now minus. No, I want to differentiate for x here. Now we have s squared. If I differentiate for s squared, it's going to be 10x y cubed. I will not write y dx because it is x. Now I will differentiate for this one. If we differentiate for this one, that means 15. That will be plus 15 x squared y squared. Y squared because because this 15 x squared y squared, because you have to subtract 1 is y squared plus, sorry for the board, the differentiation of 4y here is going to be 4. Because I differentiate for y. Now let me quickly say this again because I have to extend it to write it here. Now if I differentiate for x here, so the x here is 10x y cubed, 10x y cubed, 10x y cubed. That's what I have here. I will not write y dx because it is x. Now when I differentiate for y here, so it's going to be 15x squared y squared, because I'm going to remove 1. So this one, we are going to write the y dx here because I differentiate y. Now plus differentiation of 4y is going to be 4. Because it is y that I differentiate, is going to have the y dx. So everything equals to 0. So I'm going to pick those ones that are having the y dx together. This one is having the y dx 8yx dy dx. It's having the y dx. This one is having the y dx. And please, I want to tell you something. This one will differentiate it twice. You have to put inside the bracket. So there is minus in front. Now, this one is having the y dx. Minus times plus is going to give him minus 15 x squared y squared dy dx. Now equals to, okay, this one also is having the ideas, plus 4 dy dx. Now equals to those ones that are not having the y dx. This guy is not having the y dx. If I take it outside, it's going to be minus 4y squared minus 4y squared. And which one again is not having the y dx? And this guy. Don't forget that the minus has affected this, but when I take it to the other side, it becomes plus. Plus 10xy cubed plus 10xy cubed. So we will now factorize for the y dx. For the y dx, the y dx, I open a bracket. I'm having 8yx minus 15 x squared y squared plus 4 equals to, don't forget, minus 4y square minus 4y square plus 10xy cube. So I'm going to divide both sides by this because I'm looking for the y-dx. All over 8yx minus 15x square y square plus 4 all over 8yx minus 15 x square y plus 4. This we cancel this. So the dy dx is going to give us minus 4y square plus 10xyt all over 8yx minus 15x square y plus 4. That's number 3. Let's take like one or two more under implicit of function for better understanding. Examples under implicit of functions. I believe you are getting it. Now, they ask us to differentiate it under implicit of functions. What do we do is that you differentiate x. When you differentiate x, that will be 2x. You know, when you subtract 1 from here, there is 2x raised to the power 1. That is 2x. That is 2x y. Don't forget to write the y. You cannot write the y there because we differentiate x. Now let's differentiate y. That means plus. If I differentiate y, you know y is 1. When you differentiate a letter in calculus, that is 1 in differentiation. Y, and I'm going to have s squared left. That means s squared dy dx. Why do I put dy dx? Because I differentiate y. Now let's move. Plus. If I differentiate y squared here, that's going to give me 2y. Don't forget, I'm going to write it with this one. 2yx. 2yx. I'm going to write the y dx because I differentiate y. You know, when you differentiate y squared, that is 2y. But you have to write it with the second letter, 2yx. But because I differentiated y, that is y dx. Plus, I need to differentiate x. If I differentiate x, that is 1. Another letter is 1. So I'm going to have y squared left. So y squared. Because I differentiate x, which is 1. So I'm going to have this one left, which is y squared. And that is, I cannot write the y dx because it is what x that I differentiated. Now plus, what differentiation of 4x? 4. I can't put any y dx there because it is x equals to what differentiation of 1? That is 0. Now we'll now pick the ones that are having the y dx together. This one is having the y dx, that is s squared dy dx plus 2yx dy dx now equals to minus 2xy, because I'm bringing 2xy outside, minus y squared minus 4. I brought all of them outside. So I'll factorize I'm going to factorize for the y dx. The y dx is common. I'm going to say dy dx into bracket s squared plus 2yx close bracket equals to minus 2xy. Or you can even just say plus minus and open a bracket. When you open a bracket, it's going to be 2xy plus y squared plus 4 close the bracket. So I'm going to divide both sides by this. And I'm looking for the y dx all over s squared plus 2yx all over s squared plus 2yx. So this cancels this. That means our dy dx is dy dx equals to 2xy plus y squared plus 4 all over x squared plus 2yx. Don't forget I put this inside the bracket and the minus is outside. So that's number 4. Now let's take one more. Now let's say at the point 1, x, y. This one represents x, this one represents y. Now what differentiation of y squared? That is 2y x dy dx. Because I differentiate y. I will differentiate for x also. Plus, if I differentiate x, that's 1. So I'm having y squared left. Y squared. Now plus